Good day, everyone. Thank you for joining us. Uh, Firstly, today we are going to cover the first chapter of physical sciences for grade 12. But like, it's the chapter that they're not going to teach you in grade 12, but you're actually going to do revision for grade 12. You're supposed to know Newton's laws from grade 11. So right now in grade 12, you just have to do what revision only, right? So without wasting much of the time, today we'll be looking at section 1.1. Section 1.1, which are the basics of Newton's laws, right? So firstly, we'll be covering the contact and non-contact forces. Like we are trying to differentiate between the forces. There are contact forces and non-contact forces. So we are differentiating and trying to see which kind of forces are contact and which kind of forces are non-contact forces, right? So firstly, a force is any kind of push or pull action exerted on an object by another object. So any kind of push or pull action exerted by an object on another object, right? So that's how we explain it. And then the contact force, it's are the forces. It's the force that is exerted between objects that are touching or connecting with each other, right? So contact forces are obviously the forces that are either touching or connecting with each other, right? And the examples of contact forces we can say are what applied force. There is tension force, frictional force. As you can see, I said friction, and in the bracket I said frictional force, kinetic friction, and also the static frictional force. So those are what are the examples of contact forces, and also the normal force, right? And then the non-contact forces are the forces exerted between objects over a distance without touching or connecting with each other. The key word here to note is that they are not touching or connecting. The key word in contact forces is that they are touching or connecting. There is a physical contact, right? But in non-contact forces, there is no physical contact with each force, right? So the examples of non-contact forces are the electrostatic force and also the gravitational force. Those are what? Those are the non-contact forces, right? So the contact forces, right? So we have what normal force, and a normal force, it's it's a definition that you need to know. Non-contact forces, contact forces, and forces, they will never ask you inside a question on a question paper, right? But a normal force, you really need to know how the definition of normal force. So a normal force is the force that a surface exerts, a force that a surface exerts on an object with which it is in contact and which is perpendicular to the surface, right? You just have to know the definition by heart. Don't pick up words being like which is in contact and which is perpendicular to the surface. No, you can't just say it's a type of force that is perpendicular to the surface. No, that's not a complete definition. You need to state it as a whole to get the marks, right? So on a horizontal surface, remember F, a normal force, right? A normal force is equals to a gravitational force, right? And on an inclined plane, a normal force is equals to what? Is equals to a perpendicular gravitational force, right? That is what? That is on an inclined plane. And the perpendicular gravitational force is equals to what? It's equals to Fg cos theta, which is equals to mg. Remember, Fg is equals to mg, right? So that's why we replaced mg with Fg. So we said it's equals to mg cos theta. We replaced Fg, right? So, and the other thing you need to know, the parallel components, guys. So Fg parallel is equals to Fg sine theta, right? And Fg, remember, you can change it to mg, right? And mg meaning you have a mass multiplied by gravitational force, right? So gravitational acceleration. So right now, and then you multiply by sine theta. The difference between parallel components and what? Parallel components and a perpendicular component is that in a parallel component you're having Fg sine theta, right? And in perpendicular component you're having what? Fg cos theta, right? And then you can replace the Fg with what? Mg, and meaning you have what? A mass there and a what? In a gravitational acceleration, which is equals to what? G is equals to what? It's always equals to 9,8 meters per second squared downwards, right? And remember, before beginning any calculation in physical sciences, you need to start with the direction. Indicated direction, guys, please. And then the frictional force, it's a definition that they can also ask you, right? A frictional force, it's a contact force that opposes the motion of an object and which acts parallel to the surface. So the key points to note here is that it does what? It acts parallel to the surface, and it also does what? It opposes the motion of an object. So meaning when the object goes to the right, the frictional force actually opposes the motion, meaning it goes to the left, right? So that's what you need to note about frictional force, and you need to know the definition by heart, right? So the kinetic friction, it's they will never ask you this kind of definition in what? In an exam paper, but you just need to know what is a kinetic friction. A kinetic friction is the force that opposes the motion of a moving object relative to a surface with which is in contact. So meaning that Fk there, meaning kinetic friction, is equal to what? Is equal to mu k. That Greekish letter there is mu k, right? And remember, mu k, it doesn't have what? It doesn't have any unit. So if they ask you to calculate mu k, at the end, don't write any SI unit. And then the SI unit for Fk, it's a what? Remember, Fk is a what? It's a force, right? And all forces are measured in what? The SI unit it's Newton, right? So a normal force there, remember, its SI unit is what? It's Newtons, right? So it's mu k multiplied by normal force. Thank you for joining us for today's lesson about contact and non-contact forces. I hope you gained some knowledge throughout the lesson, and hopefully you can note down some of the notes so that you can treat and see what you were doing right and what you were doing wrong. And as always, thank you for watching. We'll see you in the next video. And remember to subscribe, comment, and share. Thank you.